another session of Concept at Fingertips. This is Vidya, Physics faculty. In another session, we had discussed the properties about magnets, and we have said that the magnet attracts magnetic materials and the attraction is maximum at poles and minimum at other points. Today, we are going to discuss about the topic pole strength and magnetic moment of a magnet. So what is pole strength? So the pole strength determines the strength by which a magnetic pole attracts magnetic material. So the magnet attracts magnetic material and how much strength with which it attracts is determined by the quantity known as pole strength. So the pole strength is it is denoted by the letter small m, and it is a scalar quantity. Denoted by the letter m, it is a scalar quantity, and for North Pole it is given as plus m. For South Pole, the pole strength is given as minus m. So this is North and this is South Pole, means the pole strength of the North Pole is plus m and that of the South Pole is minus m. The pole strength has an SI unit of, its SI unit is given as ampere meter. So from that we can write the dimensional formula as here. From the ampere we can say this is ampere to the power of 1 and this is meter, and so that will be the length to the power of 1 and mass and time to the power of 0. So this is the dimensional formula for the pole strength. And another important point here is that the pole strength is distributed entirely or cross section. It's distributed over the cross section of the entire magnet. So it is distributed over the cross section. So what it means is that if you divide a magnet into different pieces, if you cut a magnet into different pieces, for example, let us take a magnet originally of length. This is a north and this is a south pole of a magnet, and its effective length is given as 2L. Effective length is always less than the total length of the physical length of a bar magnet. So it is denoted as 2L here. And if you consider this bar magnet, if you consider this particular bar magnet, let us write the magnetic moments of that. Sorry, magnetic pole strength. Sorry, pole strength of that. It is plus m and minus m. And if we are going to divide that by cutting it in a direction perpendicular to the magnet. So we are cutting it in a direction perpendicular to the magnet. So as we already know that the magnet will create new poles. When you cut a magnet, it will automatically create new poles as shown in the figure. As the pole strength is distributed over the cross section, each of these pieces will get the same pole strength since we are not doing anything with the cross-sectional area. So this will be plus m because it is a north pole. This will be minus m because it is a south pole. But the length, effective length now got reduced to L and L. Alternatively, if we are going to divide that bar magnet, if we are going to cut the bar magnet lengthwise to two equal halves lengthwise. So the total length will remain constant, that is 12 total effective length. Again, we have, these are the poles of the new ones. So the pole strength, since it is cut into half, the cross-sectional area got reduced into half. So the pole strength in turn will be plus m by 2 at the north pole and minus m by 2 at the south pole. Same for the second half, plus m by 2 and minus m by 2 respectively. So this is all about pole strength of a magnet. Now let us see the topic, magnetic moment. Magnetic moment. Magnetic moment is a vector that is represented by capital M. It is a vector quantity and its magnitude is given as pole strength multiplied by effective length. Which means if you have a bar magnet of, as shown in the figure, if you have a bar magnet with magnetic, so this is the pole strength plus m and minus m is the pole strength of the south pole and the effective length is 2L. So in that case, the magnetic moment magnitude is given as m into 2L. So that will be the magnitude of magnetic moment. So what about its direction? The direction of a magnetic moment is from south pole towards north pole. So always oriented from south pole to north pole. As shown with, as indicated by this arrow. South pole to north pole of a magnet. So since we already know the equation or the formula for magnetic moment, we can find out the SI unit. So SI unit of magnetic moment is given as, well, the SI unit of pole strength is, we already discussed, it is the ampere meter. And we already discussed effective length also. Effective length is represented by meter. So what is the SI unit of magnetic moment? It is ampere meter square. Again, if you want dimensional formula, so the dimension can be given as, so first we write it like that, and then we see the SI unit or the formula. So from the SI unit, it's ampere. So ampere to the power of 1 and meter square. So length to the power of 2 and all other quantities to the power of 0. So this is the dimensional formula for a magnetic moment. Now let us see what will happen if you cut a magnet, like the cases which we discussed before. So if we are going to cut the magnet in a perpendicular direction, if we are going to cut it perpendicular to its length, the cross-sectional area remains same. So this is the North Pole, this is the South Pole. Again, another North Pole and South Pole will be created. This is plus M minus M, since we are not disturbing the cross-sectional area, plus M minus M. So the length in turn will become L and L. In these two smaller magnets also, the magnetic moment direction will be, it will be oriented from south to north, like that. And what will be the magnitude? The magnitude is given by the pole strength multiplied by the effective length. So each one will have a magnitude of, let's say, M dash. Magnitude of M dash is equal to M into L, which is in turn half of the original magnetic moment. So both of them will have half of the magnetic moment M. So let us see if we cut the magnet, original magnet in lengthwise, what will happen? Let us see. So in that case, the new magnets which we got will be each of them will have a length of 2L, because we are cutting it lengthwise. Length remains constant. Let this be the north and this be the south pole. Again, North Pole and South Pole. But since we are cutting it lengthwise, the cross-sectional area is going to get reduced to half. So since we are cutting it into equal halves, right? So here the magnetic strength will become magnetic pole strength will become M by 2 minus M by 2. Again, the same with the second piece, minus M by 2 and plus M by 2. Now let us calculate the magnetic moment. Again, the direction of the magnetic moment will be from south to North Pole, as shown with that arrow, as indicated with that arrow. And the magnitude, we can say the magnitude is the pole strength multiplied by effective length, or the magnitude of the new magnetic moment will become M by 2 multiplied by 2L, which is equal to M into L, which is again half of the initial value. So that's all about pole strength and the magnetic moment of a magnet. I hope you enjoyed the session. Meet you in another session with a new topic. Thank you.